We're going to look over the definition of linear and nonlinear differential equations, and we're going to go over some examples so that we can ingrain them in our memory. The definition of linear differential equations are derivatives in functions that occur as polynomials. And remember, a polynomial is x in the form of, so we have some constant. That's what our c subscript n is, or c subscript n minus 1. Those are just constants. We have constant x raised to some n power. It doesn't matter what kind of constant we have in here. The main part is that we have x raised to the nth power. It's to the nth degree. Now, a linear differential equation must only have y prime, or y raised to the nth power. A linear differential equation cannot have like y prime raised to 2, or y raised to 2, or cosine of y, or y times y prime. It cannot have any y variable with a higher power of 1, so the polynomial part kind of kicks in. Now, it's also important to note, and what I like to say is that, notice how y is inside of this. It's inside of here. If anything, it's this base to this exponent. So we can't have y inside of something or touching itself. We can't have it contaminating. So those are the two kind of ways that I really like to look at it. As long as y is by itself and it's a polynomial, it's fine. As long as it's not inside of anything, it's polynomial, it's by itself, it's totally fine. Otherwise, it is nonlinear. So let's look at our examples for this. Let's start off with this first one. Is it linear or nonlinear? Well, there are 3 y's in here, and this one looks okay, but this one, these two are touching, and we don't want that. So this one is non-linear. What about this next one? Well, we have 3 y's in here again. This y looks fine. This y double prime, it's okay. It's being derived twice. Now, where this kind of breaks is this part right here. Remember, y can't be inside of any like exponent base. So this one is also non-linear. What about this next one? Well, y, you can see it's inside of its exponent as a base, so it is also non-linear. And this next one, we have f. That is our dependent variable, the one we're looking at. So this f right here, it's okay. This one right here, it's just being derived, it's okay. So this one is linear. What about this one? Well, f right here is okay. However, f in this one is inside of an exponent. So that would make it non-linear. Now we have y inside of a square root. Remember, y can't, or y prime, or even y itself can't be inside of something like this. So this one is nonlinear because of this. Now, if we look at the next one, the dependent variable y, it's inside of a sign, it's inside of something. We don't like that, so it is nonlinear. Now, what about this next one? Well, this y is an exponent, e raised to something. It's inside of something, so because of this, it is nonlinear as well. And this last one, what about this? Well, we have our y as our dependent variable. Right here, it's just being multiplied, so this is okay. Right here, it's being derived, it's okay. And right here, it's being derived to the second power. That's also okay. So this one is linear.